Hi there. So in response to my last video where I built an amp whilst I talk about some stuff, I've decided to do a tutorial on how one can etch their own PCBs and perhaps why they'd want to do so. For me, when I started doing all this sort of stuff, I was using these. These are perf boards with individual eyelets that have plated through holes on them. And these seem like a simple solution, you know. You can just solder all your individual components on there and bam, you have a circuit. Except these are actually a real pain to work with because unlike a solderless breadboard, none of these are connected. You have to make each individual connection yourself, and that's a bit of a hassle for me, and it's something I basically hated. So I decided to go the other route with making my amp and etch the board myself. And today I'm going to show you how to do that. So let's move over to the bench and take a closer look. So here in front of me I have basically most of the things we're going to need for this procedure. We have our substrate, which I'm just using a piece of copper clad board that I just snapped off. We need our resist, which I'm just using permanent marker for. And we need, well, we don't necessarily need it, but I'm using a magnetic stirrer to help hasten the process. Ferric chloride can stain your skin, so I'm using a pair of nitrile gloves, and you should probably also too. And I'm just using tweezers for convenience for taking the board in and out of the solution without getting my gloves messy. Oh yeah, and last thing we're going to need is our etchant. In this case our ferric chloride, which I have some in this tub. No, this is not product placement. You can also use hydrochloric acid and hydrogen peroxide if you have access to that, but I just have ferric chloride, so that is what we're going to be using today. So the first thing we need to do is make our pattern, and to do that we simply draw onto the substrate using our permanent marker. Now on here I'm just going to draw a simple LED resistor circuit. So I'm going to draw our VCC pad, nice and big. I'm going to draw the trace that goes to the LED. There's going to be two terminals there. I'm going to draw another track that's going to go to the resistor. This is very imprecise because I'm not using any other methods. I'm just drawing it on here, but I'm going to talk about how to make it more precise in a bit. And we're going to make two more holes for our resistor. Ooh, this is going to be close. And our ground is going to have to be, make a ground powder there on the corner. There we go. That is a extremely rudimentary, extremely simple circuit that we're going to etch. Now, where we've drawn with our permanent marker, a permanent marker acts as our resist, and that means that when we put it into the etchant solution, it's going to completely ignore the copper underneath the resist, and it's going to etch all around where the regions are. I reckon that since this is such a small substrate, it's not going to take that long to etch. However, larger projects will take a little bit longer. So now that we have our etchant ready, stir bar goes in, board goes in, submerge it, there we go. Steering goes on, and now that should be etching. If you have a stir bar, you only need it on minimal stirring, and this should take 10 to 15 minutes. While that's etching, I thought I'd give a quick demo of my amp that I built using the same method. So here goes. So that's just some music from some random YouTube friendly playlist, so-called on Spotify. Now, this amp is being used as a preamp right now because this is a Bluetooth speaker. However, unfortunately, this amp only runs on single mono because the output jack that I'm using for this, the output cable, is only tip sleeve, and so it's only actually feeding one of the speakers. If I was to switch that cable out for a full TRS, I could get parallel mono. And if I was to make this exact same circuit twice for each waveform, I could make this amp into a stereo amp. For those wondering on the specifics, I've designed this amp around a 12 volt supply with a 30 milliamp gain on each peak, which equates to around 60 milliamps peak to peak of gain, at least according to the collector current of the transistor. So I've gone ahead and fished our board out of solution, and it now looks like this. So as you can see, surrounding where we put our resist, there is no longer any copper on there. There is only the epoxy substrate. Now all we need to do to reveal the copper underneath is we need to wash it with some IPA. And that should remove the ink. And it should also wash away any residual ferric chloride. So, and there is our result. If my camera can focus. So, we have just etched a simple circuit from a piece of copper clad board. Now I'm not going to do this in this video, but if you want to, you can go ahead and drill into these holes and make the circuit through hole, or you can design your circuit around a surface mount design. Now there's many reasons why you may want to etch your own circuit. You may have some bespoke or niche needs that require a very specific solution. You may just be a hobbyist and want to understand the science of electronics and all that sort of stuff. Or you want to just get into making more of your own stuff. Electronics is a valuable skill, and knowing how to etch your own boards is a massive boost to your knowledge toolkit in that area. Now clearly this example that I've just developed here is merely for demonstration purposes. Even for its very limited use case, which I outlined earlier on in this video, it won't really serve that very well or very reliably for very long. The pads are the wrong shape, the traces are very irregular. You can see here there's even a small gap between the trace and the what would be a through-hole plate. Now there are ways to make these kinds of circuits more precise, more controlled, and thus more reliable. An idea I've thought of is to 3D print a stencil, which I can then use to trace along the gaps inside the stencil onto a board and then etch from there. But that's just one idea. You can also strap a pen to like a 3D printer or any kind of CNC machine and do it that way. You can use a plotter, for example. And there's so many other ways. The alternative to etching is milling, and some people prefer it that way. Some people don't like the mess, and so they prefer to etch. It's still a little bit messy, but at least you don't get, dust everywhere. Dust and particulates and such. And plus, with etching, you can do it, pretty much anywhere in the home. Whereas you'd require, for milling, you would require a workshop space where you have a method of cleaning up all of the debris and such. There's also laser engraving of circuits, which I think is also a pretty interesting tool. Anyway, I hope you've enjoyed this tutorial, and I hope you found it informative. Thank you very much for watching. I will see you all next time. Like and share if you enjoyed and to help support me. Thank you very much for watching. Bye for now.